So TALOS is a MON 25 MMH engine that's designed to operate at low temperatures. So MMH is monomethylhydrazine, that's our fuel. MON 25 is mixed oxides of nitrogen at 25% nitrous oxide mixture. That's our oxidizer. So you got to have fuel and oxidizer to combust. So it is a bipropellant engine in contrast to a monopropellant engine. And it is designed to generally work on lander applications, both for lunar missions and for deep space missions. The big benefit of the MON 25 is the low operating temperature. And so the low operating temperature, as you go deeper into space, your solar arrays become exponentially less effective as you go away from the sun. And so if you're able to operate at much lower propellant temperatures, then you don't need to use as much power on the vehicle to keep your propellant warm. So that frees up power on the vehicle then to utilize for other things. Particularly important on very long planetary missions into deep space. So that's what the TALOS is designed to do. In addition, it utilizes the latest in valve technology. So it uses very rapid valves, which give it a very low minimum impulse bit, which basically just means that you can very finely control the pulse modulation of this thruster. So the amount of control that you have with a thruster like this is dependent on how fast you can open and close, or basically turn the thruster on and turn it back off again. And so this thruster is designed to operate very fast.
That is awesome. That is awesome. So where would we see this specific system in modern application, in current application?
Okay, so right now the primary goal is a lunar mission. So small autonomous robotic landers is where the TALOS is focused right now. We have a 150 pounder and a 10 pounder. The 150 pounder would be used for main propulsion applications for small landers. And I have an example here of the Astrobotic Peregrine lander. Astrobotic is a company in Pittsburgh. This is their Peregrine lander. So it could be main propulsion for that lander. We also are creating a 10-pound variant of the TALOS that's an attitude control system, or ACS thruster. So that's the smaller thrusters that make more fine precision movements to keep the vehicle balanced.
Very cool.
And so there's the lunar lander applications, and then there's further deep space lander applications, or even transfer vehicles or in transit vehicles into deeper space.
Well, thanks for sharing. That's
Sure.
awesome.